Properties, if you're going to dress up, do it tomorrow. Properties of parallel lines. Definition. A transversal is a line that intersects two or more lines at distinct points. Okay? So we got two or more lines, we got a line crossing. Label the transversal in the three diagrams shown below. So which of these guys is the transversal?
Line that intersects two more lines.
Yeah, so it's got to be this line here, right? Because it intersects two or more. See, this guy only intersects one line, and so does this. Which one's the transversal here?
The one that's horizontal.
The one that's horizontal, right? Actually, it's called oblique. Horizontal would be straight, flat, right? Like the horizon. That's oblique-ish. What about here?
The one that's
All of them. Somebody said all of them, right? Because they all intersect too, right? That one's there and there. This one and this one. So they're all transversals, right? They just intersect two or more lines. Which of the diagrams above shows a transversal intersecting two parallel lines? The left, the middle, or the right?
right.
What?
Oh, I didn't
Would you like to change that answer, perhaps? The middle. You do know what parallel lines are, right? Indicate the two lines that are parallel to each other using appropriate notation. Okay, I'm going to clear off the junk here. Make a big sweeping motion and then touch in the middle.
Oh.
I know, right? Maybe I waited too long. Oh, seriously? Like last class it worked.
Oh.
Well, that was the selection.
Oh.
I was selecting it.
Oh. There you go.
We need the round circle. Boom. Okay, so here's the notation for parallel lines. You put like an arrow on them, right? If there's more than one set of parallel lines, you put arrows on one pair and you put double arrows on the other one. And if there's three, then you put triple arrows on them, right? So that's the indication lines are parallel, right? That's how we communicate to you mathematically. These are parallel lines. If you don't see those, even if they look parallel, they're not, unless there's some other indication, okay? So it's like a 90-degree angle. How do you know it's 90 degrees?
Another square.
You see a little box in the corner, or they say angle ABC is 90 degrees. Otherwise, if it looks like 90, unless they show you the little box, or they say it's 90, you may not assume that it's 90, okay? You may be able to prove it's 90 some other way. You might say, hey, this side is 3, this side is 4, this side is 5. It matches the Pythagorean theorem, right? We have a Pythagorean triple, so it is 90. Okay, so you could do that. But there has to be some indication. So here, that's the indication lines are parallel. Types of angles formed by a transversal intersecting. So there, see, there, this has two. You can put one, you can put two, you can put three, but that's the indication. So a transversal diagram is shown. Interior angles. Angles formed by the transversal and the two parallel lines that lie inside the parallel lines. So there are 4 of them. What are they called? I heard it being sung. And they are A, B, C. Not E, F, G. Those are not. Alternate interior angles, right? So this is the vocabulary of parallel lines, right? And we have to know this, right? So when I refer to an interior angle, you say, it's one of these 4 angles. If I refer to alternate interior angles, pairs of non-adjacent. What does non-adjacent mean? So what's adjacent mean? What does it mean? Beside, right? I'm now adjacent to, right? Beside. So adjacent are beside each other. So pairs of non-adjacent. See, A and B are adjacent. So they have to be non-adjacent angles on opposite sides of the transversal. There are 2 pairs of alternate interior. So interior, that implies it's going to be either A, B, C, D. So what are the non-adjacent interior angles on opposite sides? A, C, B, D. Okay? So 2 pairs of alternate interior angles, AC, BD. Non-adjacent, they're not beside each other. They're interior, so it's A, B, C, D. So A and C, right? So they are opposite sides of the transversal. This is to the left, this is to the right, this is to the right, this is to the left. They are not beside each other. Okay? And there's a property about those, right? And that's what we're going to start examining after. But first we need the lingo, right? Need the vocabulary. Exterior angles. Angles formed by the transversal and the two parallel lines that lie outside the parallel lines, and they are E, F, G, H. A, B, C, E, F, G, H. So those are the four exterior angles, right? We have interior angles, we have exterior angles. We have alternate interior angles, right? So they're on opposite sides of the transversal, but they're interior. And we have alternate exterior angles. Pairs of non-adjacent, meaning not next to each other, not beside each other. Exterior angles on opposite sides of the transversal. Two pairs of alternate exterior angles are E, G, F, H. E, G, F, H. Corresponding angles, a pair of non-adjacent, meaning that they are not beside each other. Angles consisting of one interior, you have one choice from A, B, C, D, and one exterior, you have one choice from E, F, G, H, that are on the same side of the transversal. Okay, so what are they? One interior, one exterior, not beside each other, so EA is out. E, D, FC, Toronto, FC, ED, FC, BG. So corresponding, the way I think about it is this, right? It's in the same place, right? There's E, there's D. Where are they? To the left of the transversal and above. To the left of the transversal and below. To the right of the transversal and above. To the right of the transversal and below. Right? Those are corresponding angles. Okay. What were they? ED. Okay. So four pairs. ED, AH. What were the other two? Oh, FC, right? And whatever's left. BG. See, you can use logic at this point to say, what's left? BG. Deductive reasoning. I have deduced by the lack of a B and a G that it must be BG because there's four pairs of them, there are 8 letters, and I've already used 6 of them and so. Vertically opposite angles. A pair of angles that are opposite of one another across the intersection point of two lines. The angles share the same vertex but are non-adjacent. There are 4 pairs of them. So vertically opposite, what are they? So they have to be non-adjacent, but they've got to be on the same, what did it say? A pair of angles opposite one another across the intersection point. Here's the intersection point. So what do we got? Okay, EB, AF, DG, HC. So EB, DF, HC, because I forgot the other one, and it's got to be AG, right? Because I'm missing a G. No, AF. Oh, no, it's not DF, it's DG. DG. Okay. EB, AF, DG, HC. Or CH. Okay. Doesn't matter what order you list them in. These are vertically opposite angles, okay? So, everybody got this all written down? You need to know these terms. If I refer to vertically opposite angles, I'm going to assume you know which angles I'm talking about. If you don't, man, everything that relies on that question will be wrong, right? Any of these properties that we learned will be wrong if you can't identify the angles. Okay. So, must become familiar with all of these words. Supplementary angles. 2 angles whose sum is? I'll give it to you. We'll never get along. Yeah, somebody knew it but didn't want to say it. What if I'm wrong? If I'm wrong, I'll be embarrassed. It'll be on YouTube forever. People that know my voice will know that I got it wrong. Right? Somebody from, hey, I recognize that voice. It's so-and-so. The only one who's going to get wrong things up there on YouTube forever is me. So, supplementary angles. Two angles that are adjacent and form a. So 180 degrees is a straight line, right? Straight line has a measure of 180 degrees. Form a straight line. Complementary angles. That is misspelled. It's an E, not an I. Two angles whose sum is. Say it. No, two angles can't make two. Well, actually, they can. But two angles whose sum is 90. Yes. And for those of you watching online, I just made a 90-degree symbol with my two hands, and then they got 90. Just like that. Unprompted. Two angles that are adjacent and form a right angle. Right angle. And we know it's a right angle because we see either the square or they tell us it's 90 degrees. Right? Or we got a triangle, we can use Pythagorean theorem to say, hey, this is a 90. Or we can use slopes. You guys, we do slopes in Tennessee? Yep. Okay. So using slopes, you can tell the slopes are, anybody know? Negative reciprocals, right? So you got 3/4 and negative 4/3. That tells you that the angles, the lines are perpendicular, which means 90 degrees. All right, here we go. One of the exterior angles. You need a question like this on the test, right? So watch now. Watch now. One of the exterior angles of the transversal is shown. Determine the measures of each. So all you need, one angle, you can get all the other angles. So this angle and this angle are exactly the same, right? How do we know? They are corresponding. Corresponding says they're in the same place, they're going to have the exact same measure, as long as these lines are parallel, right? So this is 105 degrees. What's this?
105.
What do these two guys make?
180.
They make a straight line. So they add up to, so this angle is?
75.
Okay. Now, that means that the corresponding angle is?
75.
Or, because these make a straight line, if that's 105, that's 75. Okay, what are opposite angles? Vertically opposite angles are, well, what's this angle? Based on this is a straight line, and that's 75. 105. What does that tell us about vertically opposite angles? They're the same. So that's 105, that makes this 75, that makes this 75, that makes this 105. See, all you need, one angle, boom, you got 7 more. For the price of being able to add or subtract, being able to say what number adds to 180, or being able to go 180 minus 105 is, and then there you go. So here's what we know, right? Corresponding angles are equal. Vertically opposite angles are equal. Adjacent angles add up to 180. Adjacent angles are supplementary, right? Supplementary means adds to 180. Complementary means adds to 90, which really doesn't apply to anything in here, right? So really, you start with this angle, you just say, all right, I got to get 180, that's 75. I got to get 180, that's 105. I got to get 180, that's 75. You can do that. That's why the vertically opposite are equal, right? Because they make up a straight line. So these two make up a straight line, and so do these two, so these angles have to be the same. These angles have to be the same. Same reasoning, right? It all just comes down to straight line and supplementary, right? And then going down here, corresponding, right? Because these lines are parallel, so this angle is the exact same as this angle, right? So corresponding angles are equal. One of the angles in the diagram shown is 115 degrees. Determine the measures of angles A, B, C, and D. So we got 115. Where do we start? Can we immediately say, that means angle A is whatever? C is 150. How do you know C is 150?
Because they're close.
Does C look like 150? Maybe it is, maybe it isn't. I don't know. How do you know?
Because the arrows.
Well, 'cause it's a diagonal, it's a same,
No, wait, what letter are you asking about?
Well, no, I just said, give me one. Somebody said C is 115. Why?
it's like, it's one is diagonal and then there's a same, the parallel, so there's
Okay, what? So what else could I label on this diagram?
115
Where?
there, and then
Okay, and then these guys are, what kind of angles are these guys?
I forget what it is.
Corresponding angles, right? So we know vertically opposite angles are equal. We have a pair of parallel lines. This is the transversal, right? We actually have two pairs of parallel lines. Notice how these have one arrow on them indicating these guys are parallel. These have two arrows indicating these guys are parallel. So for here, this is the transversal. That's vertically opposite. That's corresponding. So C is 115 degrees. Okay, next. What do you want to do? What can I label?
65.
65, where? Well, let's start off here. So we know these two guys are what kind of angles? Supplementary angles, because they add up to 180 because it makes a straight line. That also makes this 65. Now we look and say, I have parallel lines. This is the transversal, so B corresponds to this angle. So B is 65 degrees. A is vertically opposite, so it's 65 degrees. What's up here? 115, and D corresponds to this 115 again, right? These are the parallel lines. This is the transversal, so D is 115. And then we're done. Okay? Now, what you are doing is carrying out a chain of gas reasoning, right? It's not just an accident that you sit there and say this is 115. You might not know exactly why you knew it was 115, or well, it kind of looks like it. But that's the reason it goes into it, right? We have a 115 degree angle, so one more time, let's just go there. Your reasoning might not even go in that order, right? You might start off with, that's 115, that's 65, that's 115, that's 65, that's 115, that's 65, that's 115, that's 65, that's 115, that's 60, right? You could just do that. Start here. I would probably start with this, label this as 65 right off the bat, and then label this as 65 and 115, and then say, all right, these guys correspond, and these two are in the same position, so these guys correspond, and then these guys correspond to that. Okay, and then you get all the angles, right? So that's the line of reasoning that you would go through, or something along that line. If we asked you, what's your line of reasoning, then you would have to explain it, right, in words. You would have to write down. Well, I found the supplementary angle. I know that's 65. I then went around this, I went around this, and I realized these are corresponding, these are corresponding, these are corresponding. Another way of naming angles. Which angles in the diagram shown have a measure of 125 degrees? So we can name angles in terms of letters. So name the 125 degree angle. So you start with a little angle symbol, right? Angle. Okay, give me the name. Give me E. If you say E, I'm sort of confused. Do you mean above and to the... So when you say angle E, are you talking about this angle E, this angle E, this angle E, or this angle E?
The one that says E.
Well, yeah, but you can't refer to angle E because there's four angles, right? So which how do we specify it?
B,
B,
B, E, Z.
B, E, C. Really? What's the obvious one?
AED.
Let's start with AED.
Yeah.
Okay? Because it's labeled, right? You can actually see, hey, there's the 125. So it's the angle with the automatic electronic defibrillator, the AED, right? It's one of those hanging outside the office. So if I collapse one day, when he has to run down. Somebody fast. Who's fast? Ryan, pretty fast? Is he on his phone? Yeah, you'll die.
Fast, what am I doing?
If I collapse to the floor clutching my chest, you've got to go get the AED.
I did sports medicine. I know CPR.
Oh, there you go.
Number 11.
Okay, you can start with the CPR while somebody gets the AED.
Yeah.
Okay, so this angle here, AED. So we name an angle. What else could you call it?
DEA.
Right? The Drug Enforcement Administration.
Yeah.
That's who Hank worked for. It's only in the States, right? Hank worked for the DEA. Walt did not work for the DEA. Okay. What other angle is 125 degrees? So we know that vertically opposite angles are equal, right? So we know this angle, BEC. And how else could you name angle BEC? CEB. Yeah, so here's the idea, right? What's common to all of those angles? They all have an E in the middle, right? But when you just said angle E, I said, well, aren't there 4 angles making up E? There
I
are.
meant like the area where E is like.
Yeah, I know, but the thing is, if you're discussing something, it's angle E, if you're pointing to it, right, then we go, okay, yeah, I get it, right? But to name it so that everybody says, oh yeah, I know which angle you're talking about, right?
Yeah.
So there are 4 angle E's, 2 of which are 125 degrees. What are the other 2? 55, right? Because these angles are supplementary and these are vertically opposite, so they're equal, or these are supplementary, right? So there's at least 2 lines of reasoning for why the 55, right? Or the other one is 50. I get one of them by saying these are supplementary, so that's 55. What about the other 55? Well, those are supplementary as well, or they're vertically opposite, and so they must be equal. Okay? So you have a lot of ways that you can use to figure out the angles, right? So name, yeah, because that's Remembrance Day. Name the angles which are 55 degrees. AEB. Which one? DEC. Or? So what's important? What's important? They're all angle E. Right? That's why we can't say angle E. If there's a triangle, angle E, and it's labeled E, you can talk about angle E. Well, it's that angle of the triangle, and everybody knows what angle you're talking about, right? Here, because of the crossing things, we have 2 different angles which angle E could be. So we need to refer to it with 3 letters. So when we say AED, we're saying start at A, go to E, go to D, and it's the angle formed by going from A to E to D. DEA, same thing, going from D to E to A. DEC going from D to E to C, right? So that's a D to E to C. That's what I'm doing is drawing that, right? I can move that and see, it's not bad. Pretty close, pretty close. Huh? I can do that. Oh, I got a thing at home. It's a little, it's like an angle that you open it up and it's got a little digital readout so you can measure the angle, right? It's kind of cool. I got to bring that in. Okay, math, symbols. Parallel lines. If line AB is parallel to line CD, what's the symbol we use? Yeah, so you draw basically just 2 parallel lines. So AB is parallel to, or AB. Yeah, that's about all I could think, right? It's like, oh, I should have done my homework and looked at the answers. It depends, right? It's like a web address with 2 slashes. Do you want forward slashes or back slashes? Perpendicular. How do we indicate perpendicular?
2 lines crossing over.
Yeah, so it's a timeout, but it's an upside down timeout. So this will not get you to the bathroom. It's also very hard to make with 2 hands. It's awkward. This is not awkward. This is awkward. Okay. Any questions? No. Oh, is that it? Is there more?
I mean, yeah. Yeah, it's no examples. We can just do these alone.
Oh, are they on the other page?
We can do them alone. No, we can just do them alone.
There's nothing.
Did you do a little? Oh, he lost.
Hang on. I must pause. Okay, so here's a hand-drawn approximation of what is sitting on your page for example number 1. Determine x and y, blah, blah, blah. Determine means what? Show your work. Okay, so we got to show something. So, what can I do?
3y minus.
What about it?
Write it out as an equation.
Okay, what about it? What do you want to write? I could write 3y minus 7. What's it equal to?
3y minus 7.
Yeah, we need to actually get a
Minus
solution
180.
here. 3y minus 7 minus 180. What's that equal to?
I don't know.
I don't know. I know it's got something to do with 180. Okay, we could do this. I could label that 3y, because why? What allows me to say this is 3y minus 7? What kind of angles are they? They are corresponding angles. What else can I label?
The 5x plus the 8.
Where can I put it?
Beside it.
Beside what? Like here?
No.
Here?
No.
Here?
Yeah.
Here?
No. Yes.
Here.
I don't know, because you kind of drew on this line, I don't. Oh, they're parallel.
Okay, you can do this. All right, so that means that this angle and this angle, what kind of angles are they? Got two parallel lines, a transversal. So these angles, these are the parallel lines. These angles are above the line and to the right. So what kind of angles are they? They're corresponding angles, which means they're equal. I don't know, what's the symbol? Okay, so here's the reasoning, right? Got to be reasoning. Got to determine. So you say, all right, this angle and this angle, they're alternate angles. They are equal. This angle and this angle, they are the same. At this point, then, I could say 3x plus 50, how do we say is the same as? Equals.
5x.
So you can't do anything with these guys because you have two unknowns. Don't know x, don't know y. What do I know about these two guys? They are what kind of angles? No, they're supplementary. Corresponding is in the same place. They are both above the line, but one is to the right, one is to the left. They're not corresponding. They are supplementary. So it means they do what? They add to 180. But so what? 3y minus 7 plus 3, I could do that down here. 3y minus 7 plus, actually no, I can do, I can put brackets around. I know that those two add to 180. I also know that I can't solve this because I have two unknowns. But once I solve this for x, I can put that in there, and then I can solve for y. That's the reasoning, right? So, if these two are equal, what does that mean? Well, we subtract 3x from both sides, we get 2x. We subtract 18 from both sides, we get 32. What's x? 16. Okay, now, all right, is everybody good with this so far?
Yes.
Yeah? Okay, because you're going to be doing stuff like this, or not, and then on the test you're going to have to do stuff like this, and may or may not be able to do it. Hopefully you can do it, right? So you're going through some set of reasoning yourself, right? You're saying, well, these angles are corresponding. These angles are vertically opposite, right? So just like I've labeled that, you can sit down and start labeling, right? Or you could say something like, if all you did was take this, write it up here, then you could say, look, these angles are corresponding, right? So I could do this and write in here, corresponding angles. You know, so if I say, what gives you the right to make this statement? You say these are corresponding angles, and corresponding angles are equal. Good. Okay, now we've solved for x. So we go down here, removing the brackets, we get 3y minus. Now the reason I remove the brackets is what if we were doing a subtraction, right? We'd have to distribute it through the bracket. The reason I put brackets on there is because what if we were doing a subtraction? We would have to distribute it through the bracket. So anytime you're writing a binomial is just two terms, right? And you're doing some operation on it, throw it in brackets. Okay? If you do that, you're less likely to make any errors. If you don't, you're likely to make some errors. So plus 3 times, and I know that's 16, plus 50 equals 180 degrees. Okay, what do we got? 3y minus 7 plus, what's 3 times 16?
48.
48. Plus 50 equals 180. Okay, so 3y, what's minus 7 plus 48 plus 50? You should do it in a different order, right? That's 98 minus 7, 91. What's 180 minus 90? Why are you asking that? What's 180 minus 90? 90. Minus 1 is 89. So 3y is equal to 89. Right? You don't need a calculator to subtract 91 from 180. You just do 90 and then go one more. So what's y? 20. Okay, 6, 2, 29.
Yep.
20. It's a decimal, I can't do it.
29.67.
Yeah, okay, so let's do this as 89 over 3. What's that as reduced fraction? Just hit math, enter, enter.
89 over 3.
Hey, all right. Let's just leave it. It's 89 over 3. So here's the thing about 89 over 3. It's exact. It's ugly, but it's exact. Right? 29 point whatever is not exact, right? Because you've got this decimal, and if it's thirds, you go 0.3 repeating, but if it's 6, it's 0.6 repeating. And at some point, you round it. Okay, you gotta watch your rounding, right? Some of you lose marks for rounding because it says rounded to 2 decimal places, and you decide that must mean 1 decimal place for some reason. And so I would like a half mark off here, please. And I say, great, okay, here you go. There's your half mark off. It's like a part of a Russian, a half a mark off. Okay, is that right? Okay, so if you want to know is that right, you go back in here, put 89 over 3, the 3's cancel, get 89 minus 7. What's 89 minus 7? That's 82 plus, what did we have here? 98. 82 plus 98. 98 and 2 is 100, plus 8 is 180. That works. Okay. Ugly number, right? You get to the point where you get 89 over 3 and you think, I made a mistake. You know, this must be wrong, right? How many people you think you get 89 over 3? That's got to be wrong, right? That's ugly. It should be a nice number. Well, so then plug it back in and see what happens. Go 3 times bracket 89 divided by 3 bracket minus 7 plus 3 times 16 plus 50 and say, oh, equals 180. It must be right. You can use your calculator to verify a lot of things, right? Especially on that radicals test. You can verify half the multiple choice using your calculator. Anyways, moving on. I didn't say anything. The voice is in my head. So this example, crudely hand-drawn, but should be looked somewhat the same as what you've got. This is a 2-column proof. Column 1, statement. Column 2, justification. So, statement, you get to say something. Justification, you say why you got to say that, right? So you make a statement like, angle this is equal to that. There needs to be a justification. What is the reason you're using? It's what we do anyways when we're doing it, right? It's just, it's formalized now. So you actually have to put down, right? This would be determine, you know, so, well, prove. Prove means give a series of steps. It's deductive reasoning, right? It's proving that in all cases, given that that's 100, so let's start off. Angle AED, so I got to get that. That's 125 degrees. I can label that, right? And angle ECH, that's 55 degrees. I can label that. Okay? This is what we know. These 2 lines, as far as we know, are not parallel. Like, there's no indication. We are to prove that they're parallel. Okay? So how do we prove they're parallel? Well, we have to make some statement about corresponding lines, right? So we can use alternate interior angles, alternate exterior angles, corresponding angles, vertically opposite angles, whatever else is on the rest of the sheet, angles. We can use interior angles, alternate interior, well, not interior angles, because there's nothing about interior, it's just here they are, they're inside. But alternate interior angles are equal, we know that. Exterior angles are on the outside. Alternate exterior angles, okay, are alternate exterior angles are equal. Corresponding angles are equal. Vertically opposite angles are equal. It's really easy, right? Any of these things, just that the angles are the same. Okay, so what statement would you like to make? Sure. Beautiful statement. DB is parallel to, oh, that's a justification. Sorry, I'm going to make a statement. B is parallel to GH. Why? Okay, here's the thing. You know what this is? This is the conclusion. It's what we're trying to prove. You can't start off with what you're trying to prove, right? You have no justification for making that statement. But here's how you're going to end. 3 dots in a triangle. What does that mean? Therefore, that's your final statement. Therefore, right? Having said everything else, therefore, the unescapable conclusion that we can come to is that DB must be parallel to GH. Like you're a courtroom lawyer, right? And you're just making the summation. And therefore, ladies and gentlemen of the jury, DB is parallel to GH, and my client is not guilty, right? Or whatever. Or my client is guilty. Depends who the prosecutor or the defense. We cannot make that statement because it's the conclusion. So we need to start with a statement. What do we know? Give me something we know. It's going to start with angle. Angle what? Angle DEA. That's 125. Boring. Angle AEB. All right, what about angle AEB? Angle AEB equals what? 55 degrees. Why? That's an excellent answer. Because they are supplementary angles. So you could say it's supplementary with angle AED, right? Angle AEB is supplementary with angle AED. Therefore, they add to 180, and therefore angle AEB is 55, right? That makes sense. Okay, have I justified it enough for you to say, yeah, okay, I get it? Yeah. Okay, now what can you say? So now we've done this. We know this is 55 degrees. Now what do you say? I'll give you a hint. It starts with angle.
Angle AEB
Angle AEB equals
angle
ECH. What's the reason?
because they're
Corresponding angles.
oh.
Since corresponding angles are equal, oops. I can't move just that piece. Then we make the conclusion. The conclusion is what you want to prove. Therefore, line DB is parallel to line GH because corresponding angles are equal. So if the corresponding angles are equal, then the lines must be parallel, right? That's a property of parallel lines, that corresponding angles are equal. Okay, so we start off with something which is known, right? So we label the diagram with whatever we can, which would be the 125 degrees and the 55 degrees for angle ECH. Then we start off and say, all right, what do I know? Well, so you could have said angle ECG is equal to 125 degrees. Reason? Oh, well, actually, you know what? We can't use corresponding angles yet because we don't know they're parallel. So you couldn't do that, right? So here, you can't do this. You can't say, hey, this angle is 125 because they're corresponding. That means you've assumed the lines are parallel, which is what you're trying to prove. So you can't use that. You have to work within the upper. We had to go with angle AEB is 55 degrees, right? There was no choice. To do anything down below would be assuming. You do that on a test, which is why you just assumed what you're trying to prove. X0. No, why?
Because it's true.
Yeah, it's true. In a courtroom, it would be called assuming facts not in evidence. You're trying to make something out of nothing. No, you assumed what you're trying to prove is true, and then said, because what I'm trying to prove is true, this is true. It's not true.
Not true.
Not true. We don't know that. It is true, but we can't yet know that it's true. We have to take the jury through this step by step, right? We got to say, hey, one thing you're trying to do, so if you're trying to prove two lines are parallel, don't do anything down here. Because you will have assumed they are and then start making statements, and that's just going to get you a big X. So you got to work up here, right? I know this is 55 because this is a straight line. These angles are supplementary. Oh, look, this angle is also 55. Since these are both the same, since angle AEB is equal to that, then they are corresponding angles, and therefore the lines are parallel because those angles are corresponding. Okay? Next. So, okay. Your second example of a two-column proof. You in the back, pay attention. I'm not going to mention you by name, lest somebody on YouTube know you and say, oh, she wasn't paying any attention. How expected.
Her name's Laura.
Okay, I didn't say it. Anyway. I'm just going to pick up my phone and start texting or not paying attention after you ask me to pay attention. Very few times in this course will I say you got to pay attention, but this is the beginning of two-column proofs. And, you know, as much as it's nice if you want a test to leave it blank because it makes it really easy to mark, just put a big X through the page. You can do this yourself, actually, right? So you can save me some time. This is even better. If you plan to leave a page blank, put a big X through it and write 0 in the bottom right-hand corner, right? That saves me doing it. I save ink, I save time. I'm not going to give you any credit. No, I'll give you a half a mark because you saved me time in marking this page, which you left blank, to prove your lack of any knowledge whatsoever on this. Thank you very much. Okay. If triangles ABC and ADE. Now note, ABC is a little triangle contained within the larger triangle ADE. If we know they are isosceles, then we know that this line here and this line here are the same. And we know that this angle here and this angle here are the same. Yeah, looks like an angry face. Because it has to mark your test where you leave pages blank, and then it gets angry. Because actually it gets more disappointed. So I don't know if we can make this a disappointed looking face, as in, oh my god, did they do nothing? Okay, so we know that that's true. And triangle ADE, which means we know that AD and AE are the same length, right? So we could say AD is equal to AE, and we can say AB is equal to AC. That means these two guys, BD and CE, are the same length, right? So we've got kind of three lines that are the same length. Or sorry, we've got this and this are the same length. This and this are the same length, and this are the same length. So we can also say BD is equal to CE. Okay, so we've got these three pairs, right? And what else can we say? We've got angle ABC. Angle ABC is equal to angle ACB. And we've got this angle here and this angle here are the same. So angle ADE is equal to angle AED. Okay, so we've got all those statements we can make. And all I've done is just make those statements, right? On the other diagram, you could have actually labeled everything, right? 125, 55, 125, 55, 125, 55, and all that, right? And then from there, so this is what we know. We need to put together a series of statements and justifications to prove that DE and BC, right? We want to prove these two lines are parallel, okay? Now, what you can do is you can kind of enhance the diagram a little bit, right, by doing this. Saying, well, you know, this is a line, and this is a line, and this is a line. This is a transversal, right, which goes on. And this is also a transversal, right? So you could say, I'm going to make all these lines on here. Okay? So my strategy is, you don't have to pay attention. God knows, how would I know you're paying attention? You'd be looking at me with a rapt look in your face and thinking of something else. So I don't know that you're paying attention, and quite frankly, it's not my job to care. Okay? I do somewhat, but I care more when you're talking, because then you're causing somebody else not to pay attention to me, and their mark goes down, and they don't get it, right? They don't figure out that, gee, if I had stopped talking in class and actually paid attention, maybe did a little bit of homework, I would not have a 35 in this class. I might actually be passing. And do I want to pass this class? Yes, I say I want to pass. Who wants to pass this class? Okay, so almost all the hands went up. Okay, who wants to fail this class? Put your hand up and say, I really want to fail this class, right? So I don't think you walk into any of your classes saying, hello, Mr. So-and-so or Ms. So-and-so. My goal is to score 35%, talk through most of your classes, not show up half the time, and if I do, I'll always be late, which will likely be the cause of my scoring 35. But I thought I'd let you know that off the bat, right? Just so we're clear, 35, I'm going to be really happy. That's what I'm aiming for, right? Nobody has walked into a class and told me that ever, right? And said, don't worry, it's a diploma course because I'll get 65 on the diploma and I'll pass. Now, the guy did tell me that. It was at the end of the course. He said, Angela, you have like 33%. Don't worry, Mr. Amber, I'm going to score high on the diploma and I will pass. Actually, he did, actually. Yeah, he got a 70-something and passed. You can't do that with a 30%. You can't walk into the final in this course with 35% and pass, right? It can't happen because you can't get enough marks to get up to a 50. And
100%.
not that I know of. There's talk, but it's just that. So they could this year, no. For those of you watching, this year is 2014, 2015. The diplomas will be written in January and June of 2015. As for 2016, who knows? Sure you can.
Really?
Yeah, just pay $25 plus tax.
It's $25.
And don't you keep the lowest mark?
Yeah, they give you the lowest mark. That's why you pay 25. I'm going to pay $25, so I rewrite this and keep the lowest mark. Does that make any logical sense, seeing as we're kind of just finishing reasoning? No. So what mark would you likely get should you pay to have it reassessed? Well, there's two things. Number one, you can pay to have your diploma reassessed. Like you say, there's no way I got 35% on this. I must have messed up the multiple choice, or the machine didn't read it properly or something. So you can ask for a reassessment, and you pay money. And if it's like a challenge in football or baseball, right? If the challenge is upheld and they agree with you, then you get your money back. If the challenge is not upheld, then you lose a timeout, or in your case, the money. You can also rewrite a diploma. You are allowed one free writing. Okay? In other words, the first time you go through the course, you get to write it for free. Any subsequent writings you must pay for. Do that before you write it. If you don't, you're just going to get in the mail, you get a plain letter that says INC, which is incomplete. Which means, but you say, but I wrote the exam. And they'll say, yeah, you didn't pay for it, so we aren't going to give you a mark until you do pay for it. So if you are going to rewrite a diploma, pay in advance. Go down. You can do it online even now. Yes?
What's the point of reading the lowest mark?
Oh my God. Okay, statement.
Shut up.
Hey, YouTube, welcome to my life. All right, we only have a few minutes. Let's do this. We only have to make a few statements. All right, you might want to plan out what you're going to say, right? So, how can I prove lines are parallel? Well, if I have corresponding angles that are equal, if I have alternate interior angles that are equal, if I have adjacent angles that add one, right? I've got all of those things, right? So we need to make statements and then give a reason saying, I know this is the same as this because of blah, or whatever, right? So, do we know these two angles are equal? No, and I didn't mark them as such because we don't know that. We just know if I did mark them the same, I would be assuming the lines are parallel and then marking them the same, so we can't do that. Okay, so we got to make some statements and then come up with some justifications. The goal would be to say, if I can prove these angles are the same, then I will say they are corresponding angles that are equal, therefore the lines are parallel. Okay, can I prove that they're the same? So we need to think of a way we can prove they're the same. I think we're gonna run out of time before that happens. Yeah, if we do, we'll pick it up tomorrow, and if we don't, then.
What time is this period?
In a minute. No, technically in a minute, but the clock is off by a minute, 4 seconds.
No, this one.
So it ends in about 2 minutes. Okay, so think about it. What statement can we make? So if we, so look at the end game. Anybody play chess?
Yeah.
Okay, so in chess, you try and look ahead a couple of moves. If you're a grandmaster, you're looking ahead a lot more than that. But you try and look ahead, right? So the idea is, if I make this move, they are likely to make this or this move. If they make that move, then I will make this move, and so on, right? So you plan out a strategy. And that's the same thing we're doing here. Okay, doing a proof's like playing chess. It's looking ahead a couple of moves. And really, all we're going to have is probably 2 statements and then the conclusion. So what we can do is say, if I can say these angles are the same, then I can say the lines are parallel. If I could say these angles, I could also do, this is this, and that's a check mark, and that's a check mark, and that's a dot.
How do you justify how would you justify the supplementary?
Well, to make supplementary, I could say these 2 angles are supplementary, right? And I know this because what I want to avoid is making any statement that says this is like this, because that would assume these are parallel, right? This is what we're trying to prove, so we sort of need to stay up here for a moment, and then we can move down here and say something about it. So, any ideas? We can save this till tomorrow as well.
Yeah.
All right, so you've got it. Take it home. Look at it. Yeah, see if you can come up with something. And we'll pick it up tomorrow. Just do it.
Oh, and you can throw this out.
Okay.